with all of these. So Bob is going to do a spreadsheet activity. What representations could you deal with in a spreadsheet?
Numbers. Graphs.
Graphs?
Graphs and numbers instead.
Graphs and numbers. Okay. So let's go ahead and focus on some middle school examples.
So in spreadsheets, our SOLs were collecting data, analyzing data, and using Excel, some functions of Excel to see, what is the point? What's the benefits of using Excel versus just making a table by hand? So has anybody used a spreadsheet before? What do you think about teaching spreadsheets to a student? What would be the purpose of teaching them? What's the benefits? What do you like about spreadsheets? What don't you like about spreadsheets? I don't know.
I like it does the math for you.
It does the math.
It does the arithmetic for you.
Okay. It does some arithmetic
Not
for you.
not mathematical thinking and not the mathematics. It does
Okay.
the functions for arithmetic.
Good.
You have to know which.
So as a math teacher, if the Excel does the math for me, why would I be a proponent of using Excel in math class?
It's a really good way to also see what is the best type of graph to use for it.
Okay.
Because you don't have to sit there and create a bar graph and a circle graph and all your different kinds of graphs. You can just sit there and just go through what kind of graph I want to see it in.
Mhm.
And it can take 30 seconds.
Exactly. So I think Pete, Pete was saying that, so I have just 6 students in my class. How many students do you have in your class? So think about making a bar graph, a pie graph, a line graph, a histogram, whatever, any kind of graph you can ever imagine. Think about having all 26, all 32, however many kids you have in your class, do that. To say, oh, now I can compare all my graphs to see which one is the best representation. That doesn't really seem feasible or really sensical. So yes, that is one really huge added benefit of Excel. You just highlight the area you want, and again, the try it page goes through how to do all the steps. Click on a couple of little buttons, and then boom. How's that? So now we can see our red M&Ms. I have about between 6 and 8. What number is between 6 and 8? 7. Yellow goes right to the 8. Green, I had a lot of those. Boom, orange, brown, blue. So this activity will show when you make an Excel graph, the standard is all one color, but it will show you then how to change the colors to make it pretty, because all people like to look at pretty things. And so this is all part of the activity. So how much mathematics is in this?
Just that picture, or everything you...
In this mini activity that I started to explain.
A lot.
Oh,
You have data collection, you have to organize it,
Yeah.
you have to categorize it, you have to graph it.
graph it and display it. And now what can we do now that I didn't have to spend the entire class making a bar graph?
Now you can compare.
Now we're talking about analyzing, interpreting, comparing. Now we can spend time on those higher order thinking skills that really are the mathematics, the stuff we care about. The fact that they could color in the bars. You'll have those kids, oh, I want to finish coloring. No, you can't move on, I want to finish coloring. But now, click, 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 red, yellow, green, orange, brown, blue. It's pretty, and now you don't have to worry about spending all this class time doing the actual mechanics. The technology does it for you.
I found them.
All right. We can also, we talked about comparing. So we can see along the right, again, I'll zoom out a little bit. So I just named him student 1, student 2. So if you look at the red is student 2, we can call that Johnny. And now we can see how Johnny's compares, oh, Johnny got gypped on the yellows, but he looks like he almost has a little bit less in all of his bags. So not only can you graph single data, but now we can put lots of data on a single graph. And, okay, 6 may be getting, pushing the limit onto clarity, but I think you get the gist. But now let's see, what is another way we can represent this data? So now we can see, okay, the bars were kind of cool, but now we can see which color has the biggest part of the pie. What color M&Ms did I have the most of? What color M&Ms did I have the least of? Do any of them look about the same?
Brown, close.
So these are all part of this first example activity. Other things that Excel can do, which is, there we go. Now you can kind of see. There we go. You can see everybody. It will calculate totals up here, and if you look, the little f of x is the symbol for function. So as Stacy was talking about, it will do the math, do the arithmetic for you, so it'll add things, it'll sum. It'll take mean, median, mode, it can calculate percents. This is all part of the activity, so again, you're hitting more SOLs. And there's actually other ways. So say you haven't taught mean, median, or mode yet. We'll just start with mean. What would you want to jump right to the Excel formula? Does this number really make sense? I have 8.1666666 M&Ms in my bag. No. So what kind of things now can we talk about when Excel gives you numbers like this in the spreadsheet? Like, if now you put your teacher hats back on, think about, okay, so now this is what we've come up with as a class. Now how would you explain that to your students?
Typically, the first thing kids will say is, but no one has 8 red M&Ms.
Okay, yeah, if we look.
So you gotta start talking about how could you get near that.
So not one single person actually has 8 in their bag.
Even if you round down. Oh, I round down.
Or say, okay, you can't have, again, 0.16 of an M&M, maybe we just round that up to 9, still nobody has 9. So this is just, if we look at the formula bar, this is just using the average formula. What's another way we can get an average? I'll just put it over here. Or how can we calculate average? Or if we're using this more of an introduction, if they already know how to calculate mean, no problem, jump right to the formula. No sense making them do it 100 times. So say maybe you want to teach a mean. What would we want to do?
Add each individual cell up.
Add each individual cell. So when you put in the equals, that means you're going to start a formula. I can click, and if you just keep clicking, so we start at B3, we want to add, so we do Shift plus, B10, Shift, or sorry. It adds them all up for us, we get enter, now we get the total. And if we look, or, what I always love, what's another word for sum? So we can say equals sum, and now how would we get the average? What do we do? Divide by, so now we can do equals, we can do the sum, we can divide that by 6, right, 6 students? 8.166. So these are the capabilities of a spreadsheet that you can do high-level mathematics, and then you can also break it down and start at the basics. And that's, I I guess, the point of that demonstration. Does that make sense? All right. Sarah?
Yes.
Sarah, you came in late.
Oh, sorry.
So, how are we going to add your data to the class data?
I don't know, you've already calculated it all.
I know. So, what would I have to do if I had to do this all by hand? Recalculate. So.
I got my guess.
So how many red M&Ms do you have?
I have 9.
9. How many yellow?
5. 10 green. 11 orange. 5 browns. And 13 blue.
Did anybody see what happened as I typed in those numbers? That's what I love Excel. Exactly. We didn't have to do anything else besides enter the data, and everything is now already updated. It even created a total for me, and I didn't have to do equals sum and drag all the way across. So that's, again, one of the really, really, really beneficial tools, and that is part of the activity. Somebody comes in late and you gotta. And then I think, this is my personal preference, but I think that teaching students how to use this technology has value in itself. Because when he or she graduates, they can put on their college resume, I know how to use Microsoft Excel, and that's, I think, a big deal in today's workplace. So not only is there added value in the representations for the mathematics, for the understanding of the mathematics, like breaking down the formulas or learning the connection between adding and summing, but also just the technology in itself. And if we also, I think, go here, oh, it didn't add that one. Okay. It will also automatically update your charts as well. Questions on that? So this is, if we go back to the CanLead website, this resource is here in the example spreadsheet. So if you go here, that spreadsheet that I just pulled up with the student 1, student 2, blah, 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 is in example spreadsheet for 6th grade. Oh, that should say illustration. So you can download that, have that.
In this bag, it was a broken one. So actually, we could have put in 10.667. Because it looks like about 2/3 of it. What Barbara was saying about this is a valuable tool for your students to learn anyway. Excel is the most widely used piece of math software in the world, by far. If you take all the other math-related softwares and add them together in terms of usage and sales, Excel far exceeds everything else added together. So it's a pretty universal, widespread, widely used technology that everybody should learn how to use. And there's a lot of things in your own personal finance. Your grade books are built on it. I mean, everything is built on it. And so everybody should really come out of middle school knowing how to use a basic spreadsheet. And there's a lot of things your students will be able to do with it in high school, science classes, math classes. And as you'll see throughout the rest of the project, there's a lot of instructional uses. And if the kids are real comfortable using it, they learn other things sort of incidentally. For example, how many of you spend a lot of time on order of operations? Okay, 3rd grade, 4th grade, 5th grade, 6th grade, 7th grade, 8th grade, 9th grade, 10th grade, 11th grade, 12th grade. In college, they still don't have it. Okay. You learn right away, entering stuff in a spreadsheet, how to use order of operations. Because if you don't do it right, you get wrong results right away. And so it's a good tool for them to pick up those kind of skills while they're doing something more contextual or more interesting. So it's not teaching those things in isolation, because you all know better than I that they don't get it. But they learn it when they're using a tool that forces them to use it right.
But That's not all spreadsheets can do.
Do we want to, like, give the school teams a chance to
They're,
think? Okay.
in one, yeah, I'm just gonna show you another quick example. So, actually, the 6th grade, SOL in science is very, very similar to the 7th grade SOL in math, and it's talking about probability and simulating random events. So Excel can also do that. So I went over to the science, middle school science, and again, you can go to the illustration, you can go read about the research and see the chart, or you can jump right down to the actual task itself. Try spreadsheets. And then, so this is the probability of flipping coins. Yeah, I will. It's just, is it at the bottom?
It's probably in the resource library.
How many of you use spreadsheets outside of school? Good, good.
Where did the
Is that, we're just in the science one now? Good science.
So, similar kind of mathematics, scientific thinking, whatever you want to call it, going on, linking the numbers to the graphs, talking about interpreting the data, analyzing the data, organizing the data. But here it will actually simulate random events. Sorry, Yash made this spreadsheet. I don't know if you wanted to jump in and just tell me where to go and how to navigate it.
You want to start at the probability tab at the very left corner, first tab.
Oh, sorry, here we go. I was looking for that. So, in the science activity, he actually has students actually flipping the coins. Excel has random number generators, so you can simulate flipping coins as well. And then, so he's basically just using this as an organizing tool. But that way, you can get the gist. I don't know, does anybody want to see more? I don't want to overload anybody on stuff, because you'll have plenty of time to go and read through it and work through it.
I think this is a good example of what you were talking, you asked the original question was, using spreadsheets, how many representations of math could you explore? And this is one, I mean, all of them.
Yeah.
I mean, because you're looking at that graph up there, and you could ask so many questions about that graph, like, why is it, why are there corners to it? How can you have 1.5 sets of number of throw tosses and that kind of thing? Make predictive questions and all that. With these interactive boards, you can cut, paste this quickly.
Exactly,
Into
yeah,
the
it's a
board.
shame we don't have the whiteboard here, just, and you can just be like, boop, 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 boop. Tapping right on it, you can type right on it. Exactly.
That's an excellent point. I think that, and in the activity guide that we have for you, it has questions like that you can ask if you can't think of any of your own. But also, you know, thinking about technology, we want students to gain an appreciation of what this does for them, right? So you look at that graph and you ask students, well, what are you getting from this graph? And half of them are going to say, well, I don't know, it just looks like a bunch of rolling hills, or, you know.
Squiggles.
And so if that happens and you show them another type of graph, so if you click on the full probability tabs, the second tab, it shows you the same data displayed differently. Okay. And so now you have different axis labels, and now they have a better idea, okay, of what this data is actually telling them. So multiple representations of the same data.
Barbara, do you have the interactive version?
I thought it was in there, it doesn't look like it's there.
Okay, I probably have it on my machine, because I want to show them that.
That's what I was looking for.
It's called Coins and Dice.
Yeah, where's your Dropbox? At the bottom?
I have it somewhere.
Yeah, you have it in here.
It's in Joe's share somewhere. All right. Here's another way
Yeah, this is what I,
of
so,
looking at it in teaching simulating random events, because this allows you to do it multiple times.
so instead of actually having coins and, you know, kids throwing them at each other and making a big loud mess, you can just If you look at the function, can anybody read that? What does it say?
Ran between, parentheses, 0, 1.
Ran between, what do you think that means?
Random number between 0 and 1.
Random number between 0 and 1, exactly. What would 0 be? Heads or tails, whichever one you want to label it, but exactly, one is heads, one is tails, and now we have this function, and you can drag that down to as many trials as you want. So right now we're at 100, here, sorry, you can't really see the, we were at 104, I dragged it down to 124, maybe want to drag it down to 188. And as we do that,
She's gonna do it.
we can see, again, bar graph, circle graph, and the actual numbers. You can kind of see them all on one page. So 52 to 48. What's the probability of getting a heads? 50%. How come we got 52 of them? Okay, yeah, now you can talk about number of trials, theoretical probability versus experimental probability. Like I said, that's a 6th grade SOL in science, the 7th grade SOL in math. So you can actually flip coins. You don't have to flip coins, you can do the same thing. What if I had ran between 1 to 6? What would I be modeling there? Dice. Exactly. And this is Joe's favorite function.
If you hit F9, it recalculates, so you can see that not every flip of 100 is going to give you the same thing. So sometimes you have more heads, sometimes you have more tails. Every once in a while, you'll have one that looks out of balance, and that happens. Otherwise, if you're having kids flip all the time, it just take a lot of time.
And you don't necessarily need to drag it into infinity and make your spreadsheet 9 pages long. Hitting F9 just automatically recalculates. And again, then you can collect data on that and then do histograms and frequency counts, and this could be your data. All
Bob,
right.
could you click on the 48?
Yep.
Okay, so you can see how it's counting. Right, it's a count if command.
We're gonna count.
And so we're saying count if in that range you have a 1, and the other one is count if in that range you have a 2. You could scroll down to 200 trials, you just have to extend the count if range a little bit. So it's fairly quick doing these things and adjusting these things.
Yeah, so when I scrolled it down, it went all the way to cell 188, so that's what I just changed in that little formula bar. And then that's why the bars jumped higher, because now we have more trials. So it's counting, it was only counting to cell 105, but when I dragged it, I took it all the way to 188, so.
Is this worksheet linked to the website?
Not yet. I'm gonna create, I'm gonna put the slider of the fraction one, it'll be resources for Excel. So you'll have 6th grade example illustration, 7th grade illustration, 8th grade illustration, and resources for Excel. So we don't specifically have activity guides and all that jazz for this. We have it just with the M&M's activity, but we'll put all the other resources up there for you to have fun with. Robert, you look like you had something to say?
No,
No.
but I'm just curious, can a computer actually generate a real random number? That's just something I've always wondered. Like,
He doesn't sleep at night.
you know, it has to be programmed in there, 1, 0, or 1, like, it doesn't matter, I'm just curious.
It's
You're told
more than when you make it up from your head. Supposedly humans cannot create truly random
No, but a
sequences.
coin flip could, right?
Yeah.
That's
Well,
like
if it's
nature
not,
can
if
do
it's
it.
not a weighted coin, I guess it, it's your philosophy on the universe at that point.
No, it doesn't.
you're asking purely random, right? Purely random?
Purely, completely.
No.
Yeah, someone told me that it could once, and I just didn't think that it could.
Yeah. It's,
It can get real close.
yeah, it's closer than anything that you could come up with. But again, I guess a human had to write that
Yeah,
code and.
that's what I was thinking.
I think the legend is the computer is taking a millisecond number at that time, the very, very small number of the time.
Oh,
That's how
yeah.
it's generated.
So then it could, all right, good.
But all of these things are based on sort of algorithms that you know, people have written for it. But that is a good question. You bring up a good point, though, because when you're doing stuff like this is sort of out of the usual numerical and symbolic kinds of approaches, kids may ask you questions that you may not be prepared for. You know, like this. I had a call, this was a couple of years ago, from a second grade teacher in one of your local schools. And she called me from a classroom, and she said, there's a debate going on in my second grade class, whether or not infinity is an idea or a number. And I'm not sure what to tell her. And she said, 2 kids are arguing infinity's a number because there's a symbol for it. And 2 kids are saying, it's not a number, it's an idea because you can't add it the way you add.
Where are those children? I want them.
Actually, one of them is in my house.
But if you have a father who's a math professor, this is what you do.
But they were arguing. They said, well, you know, you take infinity plus 1, it gives you infinity, so it's not like the other numbers, and you really can't nail it down, so it's an idea. So, you know, the fact that she brought up some things to explore, you got to be prepared for that. But that's good. I mean, you could be standing there saying, oh, I don't know, I'll call you back. But it's good to get kids thinking about it. And that's a great question. How does it do it?
Yeah, and if you get stuck, that's a great question. Why don't you go home and look it up? You know, Wikipedia, Google, come back and share your knowledge with us tomorrow.
Google it.
Will you give us your cell phone number?
I love getting calls like that, actually. It's great, because it shows that, you know, people are doing interesting stuff, and so I went into an explanation of countable and incountable infinity, and there's different types of infinity, and, you know.
So it's an idea, right?
It's an idea, and it's...
Just want to make sure I have the right answer for it.
I think opportunities like that for us to model, I mean, they're what we do as learners.
Yeah.
And that, you know, we don't have to know everything. We can't know everything. And it does
That's part of the fun.
kids a disservice when we pretend like we do.
Exactly. That's